Sorry guys, I had to stop the video, and if you don't know, I'm using open broadcast software these days for recording, and the quality is very good. The size of the video is very small. The problem, however, is that I can't pause the video. I have to stop the video, end that session, and then come back. And I tried actually more than few different video editors, and none of them produced a video with the quality and the size that Open Broadcast was developing. So for example, a 300 megabyte video near 1.5 hours would be compiled to something like 2 gigabytes, or I had to reduce the resolution of the screen. So I decided to stop the video. Anyway, that was an early exit for previous video. I'm sorry, I'm apologizing for it. But it also gave me an opportunity to look at my notes, and yeah, we are calling the base initialize, but we are not calling the base.tick. So that's that. So after the base initialize, we want to set our state. So state equals to, and why are you not happy? Evaluation state dot inactive, and I don't have it yet, so inactive. Okay, now let's see why I'm not happy with the state, because I didn't add it in the base. So graph, yeah, there is no base there. And you may say that, hey, why are you adding it to the base graph class? Well, here is the reason. Although we are developing a behavior tree right now, but later on, for example, if we are developing a dialog system, again, we will have a state on that dialog. So I don't see any system that won't have this, so I will add it. Evaluation state, calling it state. Okay, that's it. And you notice that I'm not doing any fancy conversion on negate mode or anything like that on the graph, because the graph won't have that. Okay, so we have the state, and now we need to add the inactive to our evaluation state. After that, we come into tick. Now tick, first I will say active node.tick, and not ticked, tick. That means that in my node, I should see that if I have any method called tick. And of course, I don't have any method called tick. So we need to add that. And I will add two things actually to the base node class. Public virtual evaluation state tick for tick, I said, thank you. And for the base, I will return evaluation state of inactive. Okay, and it's public, so I will move it on top of the protected. And the next one is public virtual void reset. In here, I will set the state, the lower state, to the inactive, and also I will call the ticked property, and I will call it to false. Set it to false, not call. So that's that, and we don't have anything else here, so that's bye-bye to node and graph. So I will have something here for BT base node, active node. So we cast it to the active node. I can't talk. We cast active node to the behavior tree base node, and we call check possible running child. Now, what is this method? And by the way, I could go back and forth between classes. I don't like it, so I'm putting everything here. And why are you yelling at me now? Oh, look at that. Cannot implicitly convert type bus-based enums evaluation state to system data evaluation exception. Means that I screwed up. Yep. Evaluation state. Thank you. Okay. So this method will basically, whenever we tick our graph, it says that, hey, active node, check if you have any child that is in running state. This method will go inside the children, check them. The very first one that it finds as running state, it will set it as active node. Why this is important? Well, let's for time being comment it, and we will come back to this line and you will understand why it's important, because sometimes I would decide to, put myself in running state, but then go one up and put the active node as my parent. So the next tick, we need to go back to ourselves that we're running. Now, I'm not sure if I'm using it anymore. That is why I commented it for time being. But here we say in reset, if nodes dot is null or empty, simply return. We don't have anything to reset. Then we say if start node equals to null, we do two things. First of all, I set my state to be errored. Okay, then I will throw an exception, new exception. Tree has no start node, and I need to do that dollar thingy here, and then the graph name. Okay, after that, so now we know we have a start node, we know everything. We say active node equals to start node because we are resetting the graph. Okay, then for each inside our nodes, var node, we call node.reset, and finally we set our state to be inactive, and that's our reset method. Okay, this, can you believe it or not, all the code for our behavior tree graph itself. We had done most of our job in our chapter 1 when we were developing our graphs base. So we are using everything that is there. We are just implementing few methods here and there, and that is it. Now we have everything in behavior tree. And because we are inheriting from graph is a scriptable object, so we will be a scriptable object, blah, 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 blah. Good. Now, schema, on the other hand, is a bit involved. In a schema, we only override some methods. And I totally forgot that we need to inherit from graph schema. And now we override the delete node, the initial setup, add toolbar item, and add menu items. Okay. Now, in delete node, before calling the base, we say if the node schema that we sent in is bt start node schema. Oh, schema. And we don't have it. So we will create it. But basically we are asking if we are a start node. Then node schema dot is selected equals to false and return. Don't do anything else. Otherwise, delete the node. So we don't delete the schema of the start node, and we don't delete the start node because we are returning early here. Initial setup. Well, we call the base. Then we say var start node. Remember, initial setup is being called at the graph generation. Okay? Start node equals to create instance, and here we can use the strongly typed, so start node, not that node. Okay? So we create a start node, then we say start node dot parent graph. Oh, we don't have it yet. So I don't want to come to these guys yet, but looks like I don't have any other way. So I will add them, I will stop them, but I won't do anything. Nodes, inside nodes, I will have bt base node, and then bt base node will inherit from node, import the namespace, it will be abstract. Then I will have a class bt start node. Now for bt start node, we need to annotate it with a node in attributes, and it inherits from bt base node, and that's it for the stubbing. Now we can import the namespace, and did I have that stuff here too? No? Okay. I commented it out for time being. Okay. So in the schema 2, we will have nodes, bt base node schema. It inherits from node schema. And remember, for the schema, this one is abstract, sorry. Then we will have bt start node schema. This one needs to be annotated with the node attribute, okay? Because the system will look for the namespaces based on that attribute, and it's bt base node schema. Now that I have them, I can continue without any errors. Finally. So we say start node dot parent graph equals to related graph. Then we will have start node dot node name equals to start. Start node dot name equals to start node. Related graph dot nodes dot add the start node. Start node dot initialize asset database dot add object to asset start node comma related graph. This is why I'm doing the start node inside the schema. Actually, I tried the first time I was developing this and put that base initialize method inside the base graph class. I was thinking about this. I had to create a start node, and the start node is a node, not the schema. So let's do it inside the graph itself, not the schema. But then I found that, hey, I need to call editor stuff, and the base graph is sitting on a non-editor project. So I had to move everything here. Then cast to behavior tree related graph dot start node, and yeah, import the namespace. Look at the namespace here again. You kidding me? This is bothering. This is now really bothering me. Okay, so that became redundant. So cast to behavior tree, the related graph, it's a start node, of course, equals to our start node. Then we want to create the schema, so var start node schema equals create instance of type bt start node schema. Then start node schema the parent graph equals to, well, this start node schema dot related node equals to start node schema dot name equals to start node schema, and we call our own nodes dot add start node schema, then start node schema dot initialize start node schema dot node rect equals to new rect. Now here I want to put my start node at the middle top of our work view. So we say node editor window dot instance dot work view dot view rect dot width divided by 2 minus 36 comma 10 comma 72 comma 40. Then we say asset database that add as object to asset the start node schema to this, not those, this asset database that finally save assets and asset database that refresh. You notice that I'm not checking if this guy is null here and nor here. I assume that if it's null, it will throw an exception on one of these lines. So yeah, that's it. Now, you remember that in here, graph editor view toolbar view, we had this commented part. Let's cut it, come back here, and this is where we are adding the toolbar items. So we don't need to call the base is empty, so that's that. And please uncomment it, and boss base if, oh, that's okay, but you notice that now we have tons of errors basically. So we need to fix that. We say var GUI style equals to graph toolbar view dot instance dot view scheme dot get style. The style that we want is toolbar FA. View rect. Before that, we need to say GUI style that font size equals to cast to int graph toolbar view dot instance dot view rect dot height minus 10. Then for the view rect, basically we need that part here. graph toolbar view.instance dot, because we have the view rect there. So we are using it there. And I will simply add a var here, getting rid of that error. Paste and paste. Now, the only part is to add the code. Here, we say related graph.tick. Here, we say related graph.reset. And we assigned our stuff to the graph again, okay? The buttons. Then we will have this fun part. Well, we say menu, and what did I call this guy? OBJ? Well, this is not OBJ. This is menu. So menu dot add separator with no text. After that, we want to start adding our own nodes here. We don't have any nodes yet. Which one to add first? I will go with the easiest ones. So I will put a space there. Menu dot add item, new GUI content, and that is decorator / success, comma false, comma the callback method, and the node name is bt success. Copy that, paste it, and this is fail. Let's stick to the node failure. So this is bt failure, and that's it. Okay, so from now on we don't have anything to do in our schema other than coming and adding more menu items to create our nodes. In behavior tree, I may come back to this guy and add our comment back if I see it's needed. And that is basically it. Yeah. That's it for this episode. In next episode, of course, now we need to come back to our base and start and their schemas and add our codes to them so that they start being a real behavior tree nodes. And I will talk about the rules of behavior trees in next video. Have fun, everyone. Bye bye.